Hi everybody, we're about to start our next unit and it's called Rational Functions, and this is notes number 21. It's actually in our book still part of chapter 3, but they kind of dump it all together in one section, and I'd rather take several days to talk about this and break it down a little bit more. Still, it is going to be a pretty short unit, only like 5 days or something like that. Okay, so I'm going to front load you with a lot of information today, and then we'll kind of just add a few more pieces as we go through the next few days. And the first thing I want to show you today is what we call limit notation. And limits describe what the y values are doing as the x values go a certain direction. So I'm going to use this graph and use it for several examples of how to do limits. Okay, as the x values approach infinity, the y values are approaching what? So let's take a look at this part of the graph right here. As x gets larger and larger, x approaches infinity, it looks like the y values are just getting closer to that dotted line that's at a height of 2. So we would say the y values are approaching 2. Now, for limits, there's a special notation, so it will look like this. You use an abbreviation, LIM, and then under it you say what x is doing. X is approaching infinity. And then next to limit you say y, so it's the limit of y as x approaches infinity. And that will equal whatever y is getting close to. So y doesn't have to actually equal 2, it just has to get close to that number. So the way we would read this is the limit of y as x approaches infinity is 2. Okay, what about as x values approach negative infinity? So now we're looking at what's happening over here on the left of the graph. And it's looking like the y values are again approaching 2. They're coming at it from below instead of from above, but that's not important to the limit. The limit is just saying what you're getting close to, what you're getting infinitely close to. So the limit of y as x approaches negative infinity is 2. Next, let's look at what happens as the x values approach negative 2. So we're looking at, let me get rid of that one and that one. We're looking at right here. As x gets closer to negative 2, from the left and from the right, the y values are getting really close to 1. You can see there's an open circle there. So x does not actually reach negative 2, 1, that point, because of the open circle, but the y values are getting closer and closer to 1. So we would say the limit of y as x approaches negative 2 is 1. I have a few more, same picture. As the x values approach 0, what are the y values approaching? So as x gets closer to 0 from the left and from the right, notice that the y values are getting close to 0. They actually do reach 0. That's not important for the limit, it's just that they're getting close to 0. So the limit of y as x approaches 0 is 0. Now I'm going to show you what we call a one-sided limit. So as the x values approach 1 from the left, notice I didn't write negative 1, I wrote 1 from the left. From the left is the little minus sign after it. So I'll write that up here, approach 1 from the left. What are the y values approaching? So we're just looking at coming in this way. What's the graph doing? The graph is going down toward y values, I guess toward negative infinity. The y values are just getting lower and lower and lower. So we would say the limit of y as x approaches 1 from the left is negative infinity. And then let's also look at what happens as the x values approach 1 from the right. So we put a little plus sign after it. Sometimes you could say from above or from below instead of saying from the right and from the left. So this one is from the right. Okay, so we are looking at coming in this way. What's the graph doing? the graph's y values are going up toward infinity. So we say the limit of y as x approaches 1 from the right is infinity. Okay, now these dotted lines that you see on my graph here, this one here, we call that a horizontal asymptote because the further out you go to the left and the right, the closer the graph gets to that line. And then this one here, we call that a vertical asymptote. The closer x gets to 1 from the left and the right, the closer our graph gets to that vertical line. So the word asymptote looks like this. And for horizontal asymptotes, I usually write HA, and for vertical asymptotes, I write VA. Okay, so for this unit, we're going to focus on graphing rational functions. Rational functions have a polynomial numerator and a polynomial denominator. It could be something like x squared minus 2x plus 1 over 3x to the fourth minus 4x plus 2, or whatever. That's a polynomial over a polynomial. We just studied polynomials in our last unit. But we're starting out with a simpler one, and we're going to build from there. So this is the simplest you could possibly get, y equals 1 over x. In fact, I think we have this one in our basic functions that we graphed from chapter 2, I think. Maybe it was chapter 1. And we made 6 or 7 different basic graphs. So this one is called the reciprocal function. Now, if you don't know what something looks like and you have to graph it, one option would be to use a calculator, but then if you're using a graphing calculator, you kind of have to know what window to set to make the points show up. So back to the drawing board, what we typically do is plot points. So let me choose some values of x. How about -5, -1, -1/5, 0, 1/5, 1, and 5. I chose those numbers because I think they're going to work well with the graph paper that I have available. So if x is -5, y is -1/5. If x is -1, y is -1. If x is -1/5, y is -5. If x is 0, we have 1 divided by 0, so that's actually undefined, so we're not going to have a point there. If x is 1/5, y is 5. If x is 1, y is 1. And if x is 5, y is 1/5. So I'm going to plot those points. And you can just imagine what's happening with other points. Basically, we're going to get this curve on the left, and then on the right, we're going to get this curve. Let me try that again. Okay. So that's what the reciprocal function looks like. It has asymptotes. Notice that as x goes to infinity or x goes to -infinity, the graph is getting closer and closer to a height of 0. It's getting closer to this horizontal line. So the horizontal asymptote is y equals 0. And also notice that as x gets closer to 0, the y values are getting closer to this vertical line. So the vertical asymptote is x equals 0. So here's what I want to do now. To build on that basic one, we're going to use our concepts of transformations that we've learned. So notice that instead of 1 over x, I have 1 over x minus 1. So I've replaced x with x minus 1. What does that always do to a graph? Transformationally, that would always shift it to the right one. Okay, so then what I'm going to do is shift my vertical asymptote to the right one. Now if I shift my horizontal asymptote to the right one, it doesn't move. And then if I shift those points that I plotted, oops, that one was too high. something like that. Here's the graph of y equals 1 over x minus 1. So let's write the asymptotes. For the horizontal asymptote, we have y equals 0. And for the vertical asymptote, we have x equals 1. Notice, if you were to think about the domain of this function, remember when we did domain, you look at the denominator, what makes the denominator 0? It would have to be x equals 1 makes the denominator 0. So the domain is x is not equal to 1, because we can't have 0 in the denominator. And the vertical asymptote is x equals 1. So the vertical asymptote is the number that makes the denominator 0. We can't have a point there. So instead of a point there, we have an asymptote there. Now for each asymptote, we have 2 limits. 2 limits per asymptote. Keep that in mind for future problems. So we're going to write the limits that go with each asymptote. So for the horizontal asymptote, you always have the limits as x approaches infinity and as x approaches negative infinity. Okay. So what is the graph doing as x approaches infinity? What is the height of the graph? Right over here, you see it's getting closer and closer to 0. What is the graph doing as x approaches negative infinity? You see over here, the height of the graph is getting closer and closer to 0. Now, it is no coincidence that these are 0 and this is 0. That's always going to happen. So writing those limits should be very, very simple if you know the horizontal asymptote. Okay, the vertical asymptote was x equals negative 1. What limits do we need for that? Well, in this case, we're talking about what's happening as x gets close to that from the left and from the right. So these are going to be one-sided limits. The limit of y as x approaches 1 from the left, and the limit of y as x approaches 1 from the right. So as x approaches 1 from the left, we're talking about this part of the graph. The y values are going down to negative infinity. And as x approaches 1 from the right, we're talking about this part of the graph, and the y values are going up to infinity. So when you have a vertical asymptote, you're always going to see your graph either going up to infinity or down to negative infinity. It could be opposite directions on either side, or in some cases it will be the same direction on both sides. For example, you could have one that goes up on both sides of a vertical asymptote. So what you can always expect is that these numbers here are going to be infinity or negative infinity. And it's going to be to the left of that number and to the right of that number. Okay, so we're actually about halfway through the lesson that I had intended to give you today, but I feel like it's going to go too long and I really want to take my time in explaining these concepts to you. So I'm just going to end there for today and pick it up next time. So what I'd like you to do for your assignment is the limits worksheet. It's going to be really quick, but I just want you to have a chance to practice what I've been talking about so far in today's lesson. Thanks, everybody.